Hello. Hi, Vinayak. Good. I think we're good to start in a few more minutes. We are waiting for everybody else to join for the session. Right, guys, just to confirm for all of you, I hope you have downloaded the Altair HyperMesh software. You might have applied with the instructions that are given in the website, I believe. Just confirm if all of you have the software to attend this course today. Okay, this was just asking for you that if you have downloaded the software. If you have downloaded the software, just let us know yes or no, because you will require the software to practice. Okay, so okay, if you have not downloaded it, it would require time. There were instructions, Vinayak. Have you provided the instructions for the learners to download the?
Yes.
Okay. Right, because there was instructions that are provided, in the registration website, right? When you basically log into the LMS in the course, you will see the instructions inside the course and how to download it. It's just not a link that you can download the software. So, Mr. Sandeep, you can actually visit our LMS. Vinayak, if you can just share your screen and show the instructions that are provided, maybe it would be pretty easy for everybody else to understand.
Sure. Can I just share the video link for them, like how to download and register?
Yeah, that should be fine as well.
Yeah, it's there in our YouTube channel. I'll just share the link with them.
Yes, definitely you can share it across. Or else, if you would like to share your screen and show it across also, it's fine.
Yeah. You guys can go through this link and watch how to download and register the Altair website. I've shared the link.
All right, so okay, because if you have not downloaded the software, first of all, you have to apply for you to get the software. All right, it would take some time for you to, apply and then get the login license for all of you. So I think you guys can just progress on that steps. But in the meantime, we'll get started with the course from today onwards. By the way, welcome all of you to the bootcamp on automotive CAE. It's a 3-day program hosted by Decibels Lab and delivered by Ms. Tara. As a part of this 3-day bootcamp, we will be working on the combination of theory and practicals. The practicals will be happening through the Altair software. So that's why we have already given you the instructions inside the course on how do you download the software. We would have preferred that you would have already applied, because it may take a couple of days for you to get an approval to basically download the software. All right, and then get it installed and set all of your system right. But anyway, if you have done it, perfect, awesome. So if you have not done it, take your time and do it within a couple of days. All right, and then you can also get an access to some of our recorded lectures. You can practice the course as well. So with this note, we're really glad that you guys are interested to explore your career in the areas of automotive CAE. I'm sure that's your decision to progress in the areas of automotive CAE. Before we get started with the course, we would like to know some of your expectations from this course. And let us know what are you expecting to learn out of this course, so that we know this is your expectations, and we will try to meet such expectations out of this course. Right, so you have an option to unmute yourself and then share your inputs on what is your expectations are. Accordingly, we will align ourselves to help you in learning. Any one of you can unmute. You can also you can unmute yourself and tell the inputs, or you can also just send the details in the chat box as well. So let's set the stage before we get started. So yeah, over to you. Anyone who would like to share your expectations for the program? Guys, anyone? You have any specific expectations to attend the 3-day program? All right, so anyone? Great, so no expectations from anyone. That's good to know. All right, so with that note of understanding, we think that possibly you are here to pick some skills to understand what is CAE, and how you could possibly align yourself to be possibly a CAE engineer. So good, pretty good to know from all of your side, and we'll get started with the session. So as I said, it's a pretty much engaging and a hands-on session. It would be good that you pay a lot of attention in learning this course, and then this would help you to transform your career and build your career also in the areas of automotive CAE. So with that note, I hand over the session to Tara. Over to you, Tara. Thank you. Okay. Tara, you have any difficulties in unmuting?
Hello?
Yes, Tara, we can hear you now.
Okay, sir. Shall I start, sir?
Yeah, please, you can go ahead.
Yeah, thank you, sir.
Thank you.
Yeah. Hello all. Welcome to CAE Bootcamp. This is in 3 days bootcamp session. In this 3 days bootcamp, we are divided into module 1, 2, and 3. Like in the module 1, we are going to learn like what is HyperMesh, what is the need of the HyperMesh, and before doing this HyperMesh, the basic fundamentals of finite element analysis. Why it is required, what is the finite element analysis, and we studied one subject in our college or in our academic studies. We have did one subject called finite element method, and what is the difference between these two. And after this, like GUI, the graphical user interface of HyperMesh. Let's in the module 1, we are going to learn the GUI of HyperMesh. In that way, we are going to learn the file management and working with panels, and what is the CAD, like how the CAD looks in HyperMesh. Those things we will learn in the module 1. In module 2, we are going to build the 2D modeling. What is in 2D modeling? How the 2D modeling look like? Okay, before doing 2D modeling, do we any prerequisites to do any like a geometry correction or extracting the mid surface? After creating the elements, how to finalize the elements? What are the required parameters set for the quality of the elements? Those things we will learn in the module 2. In the module 3, we are going to do the 3D modeling. As the name indicates, the 3D modeling applies for the solid geometry. How the solid geometry is. In the solid geometry, we can go with the hexa or tetra elements. So what are these elements? Like how to create or how to build these elements in a given geometry. These things we will learn in this bootcamp. So we'll start with the module 1, that is getting started with the HyperMesh. And I hope you already downloaded the HyperMesh softwares. It's good to have if you're already having a tool with you, so that you can practice with me. First, I'm going to start with the bootcamp with a finite element method. What is a finite element method? And what is the difference between the method and the analysis? Basically, the first thing we should know, the finite element method is nothing but dividing or discretizing the component into equal or unequal number of parts. That is what we are studying in the academics. The method means that there is a differential equation. We are going to solve the equation in the academics and we are coming up with the results. But in analysis, when it comes to the software part, what is the software is going to do, and what is the theory behind it work? These things we learn one by one. Like finite element method, as the name indicates, so what we are doing in the system, or by using any CAE software, what it will do means, see, as we can see, the name indicates the finite. It means the defined numbers. Like with say, for example, 100, 200, or lakh number of, it means all the numbers are defined. So when it is defined, so that I can define my elements within that boundary, then I can apply any method to solve this problem in a simpler way. If I want to tell, see, as a circle, we already know as a circle has infinite degrees of freedom, and to solve any finite element analysis, we require degrees of freedom. And we know what is degrees of freedom. Like degrees of freedom means any point that see, in this complete of circle, we don't know how many number of degrees of freedom are there. Basically, we have 6 degrees of freedom, that is 3 translation and the 3 rotational motions. So based on these things, we are going to build the finite element analysis. So how we are going to build, whether we are going with the quad element or tetra elements or so on, the elements which are available in the CAE industry. But when it comes to the finite element method, how it will work means, say, I'm taking this circle. In this circle, I don't know how many number of points are there. And to define a circle, we can use infinite number of points. But when it comes to the finite element means, as its name suggests, I need to define with a finite number. I should define with this finite. So first I'll go with the 3 nodes, then it become a triangle. If I go with the 4 nodes, it will become a quad element, then so on. Like how many number of lines if I want, so that I can divide this one. See, the definition I have kept it here. Any continuous object has an infinite degrees of freedom. When it is an infinite degrees, I cannot able to define the degrees of freedom. If and only if I define the degrees of freedom, then only I will get the solution. If the degrees of freedom is I'm not unable to define, means I'm not able to going to evaluate the equation. If the equations are not defining means even the software will not work. And even for our academics also, we cannot able to solve the problem. So basically what we need to do, first we need to define these things with the number of nodes or number of elements. Then we need to define the degrees of freedom. So how we are going to degrees of freedom means for a shell element, we are going to define with the 6 degrees of freedom. For a solid element, we are going to define with the 3 degrees of freedom. See, basically the number of nodes or the number of elements what we are going to create is directly implies to this component or directly implies to the result of that component. So what we are going to do in the finite element method means taken any example. So for that any component or any solid part, I am going to define with a no number of points with the degrees of freedom. What I'm going to do in the finite element means I'm bringing this component or I'm bringing this circle from infinite to the finite number of nodes. So how I'm doing? So after from infinite to finite means the 3 I'm doing. So first what I did, I have created the 3 nodes, that is finite. The entity of joining these nodes is called elements. The entity of joining these nodes is called elements. As we know, the method I'm using the finite element method, you can use the numerical method, analytical method, and the FEM method. So by using these 3, we can solve the finite element method or analysis. The difference method and analysis means in the colleges, we call it as a method. In the industry, we call it as an analysis. Basically the finite element method means like I'm dividing one component from infinite to finite with a no number of degrees of freedom, like with the element shape of quad, tria, or hexa. Like this we are going to define. I'm just discretizing or dividing. As the name suggests, I'm going to divide one component with a discretization or meshing. The giving the connection for the nodes is called elements. This is the fundamentals basic behind the finite element method. Then this is the overview of the finite element analysis. This is what the flow chart, the flow chart, I have kept it here. This is the flow chart that the industry is following. This is a standard finite element analysis process. Since we are using HyperMesh as our preprocessor, all our major work will be done in the HyperMesh, starting from importing the CAD. See, in the HyperMesh is a pre-processing CAE software, and this is not a design software. The design software are separate, CATIA, UG, ANSYS, so on. The CAE softwares are HyperMesh, ANSA, ANSYS. So these are the pre-processing softwares. So basically, the HyperMesh, like Altair HyperMesh, what we are using. First, we will import the CAD. For that CAD, we need to do some cleanup as it is done in the design software. So we need to modify or we need to edit the geometry as per our requirements. After doing the geometry cleanup and all, we are going to create the elements on it. That is called meshing. Like meshing means we are going to keep or we are going to create the elements based on the component or based on the requirement. Say for example, we are 1D, 2D and 3D elements which are available in HyperMesh to build any kind of geometry. Say from the 1D component like a bar element, rigid bar element, beam element. So like from sheet metal components, the 2D components are to the solid ones. So by using these 3 kinds of elements, we can build any kind of meshing or any kind of model. After doing the meshing, we are going to assign the material properties based on the project requirement and based on the component. And then we are going to apply the loads, like whether we are going to apply a force load, pressure load, or temperature load, then we need to fix it and the load steps. See, all these processes or all these steps will be done in the HyperMesh. Then we are going to choose one platform, that is an OptiStruct, Radius, LS-Dyna, Abacus, so on. So we are going to choose one platform to run the pre-processing, to run the HyperMesh file which we build. Then what we are going to do, then we will extract the results in the HyperView or HyperGraph. That is the visualization process. It means after doing all the analysis, after creating elements, running analysis, loads, everything, we need to view the results. Results in the sense, stresses are the displacement plot, strains. So we are going to extract all these results using in software HyperView or HyperGraph. These two are the post-processing software. See, this is the standard finite element process that every CAE industry is following to build any model from scratch to the results. This is the process which we are following. In continuation to the next, like we have discussed all these things. Okay, what is the machine? Like just now we got a little idea on pre-processing and the post-processing things. But what is the need of simulation? Okay, what is the need of the CAE? In the earlier cases, in the decades back, we have learned only, we know what only the design softwares. Okay, the designer is going to build something, then it will go for the manufacturing, and then for the production, then for the distribution it will come. So what is the necessity of the CAE? The necessity of the CAE comes in the earlier sections, or in the in the previous years. Like a designer will build the CAD data, and it will come for the virtual test, then it will go for the manufacturing. After the manufacturing, the prototype test will be done. Like prototype test in the sense, like before releasing any automotive parts or anything. Now the CAE industry has occupied everything rather than the automobiles. Say for example, for the mobiles applications or household applications, even for the television sections, electronics items, it has occupied everywhere. So what we need to do after designing, manufacturing, and building that one, we need to test it. Say for example, crash test or durability test, or for any other test. So we need to create one prototype for that. Then we need to test that. After testing only, we can release for the market. If it is failing in the test, again it will come for the designing process. The same steps we need to follow the things. Say for example, in a shorter way, if I want to tell, say you have built one square box, just assume that you have created one square plate. Then it will then the virtual test will be done, and it will go for the manufacturing. Then the test that the plate will come for the crash or the drop test. What if it is failing? The designer will suggest to increase the thickness of that. So again it will come for the design process. We need to do the modifications, everything. Then it will come for the test again. So it consuming so much of time and the money and the manpower. So to overcome all this, the existence of CAE has come. In the CAE, what we are going to do, in the CAE, the conceptual design will come first. Then it is done in the CAD software. Then in the CAE software, by using the virtual test, that is online, by using any the CAE software, here only we are going to do everything. Say for example, as I taken one simple plate, no, for that plate, using in CAE software, I can run with the 2 mm, I can run with this 3 mm, or I can change the material, or I can change the design itself. Instead of having a sharp corners, I can go with the round corners also. I can go whatever the modifications I want, I will get it in that CAE only. If not the accurate one, but I can get the approximate things. Instead of spending 10 prototype tests in the earlier design process, here I can reduce it for the 2 prototype testing. So this is a major advantage using in CAE software. By using the software, we can change any material, any dimensions, any designs, whatever you want, you can execute in the CAE only. So you can extract the results, you can build the model, you can apply whatever the load you want. Either you can go with 100 Newton first, then 50 Newton, or how much load, the actual load you want, everything, you can check it in the virtual test. After getting an approximate result from the CAE software, then the component will go for the manufacturing. After manufacturing, it will come for the prototype test. In the CAE only, we have almost got the approximate results. Then it will reduce the prototype testing. The prototype testing, it means that is actual testing. Like they will take one actual car, then they will hit that car, or they will do some crash tests or any other test, whatever they want, they do, or durability test. Those things will be done in the prototype testing. So by using in CAE software, you can reduce the time frame, you can reduce the money, and it will reduce the manpower also. So that within a shorter time, you can get the whatever the product you want with a defined set of values. It means whether you can play with the material, dimensions, or designs, or any other thing, whatever you want, you can do it in the CAE, and you will get that exact approximate results. You will get it. This is a major advantage using in CAE software. To explain this easily, you can see this air wing. See how big the air wing is. To design this one and manufacturing this one, it will take so much time. If you are not doing any CAE software or any CAE simulation, directly we are taking this for the examination, that's for the prototype testing. What if the displacement is more for this component? What if the stress values are more for this air wing? Again, this air wing will go for the design. Okay, whether he will go for checking for the material, whether he will go for adding any stiffeners, whether he will go for reducing the mass or increasing the mass. There are so many processes if you are not using this air wing, if you are not using the CAE software. But the same thing can practically can be done or can virtually can be done using in CAE software. As I said, you can change the stiffeners by adding any ribs or changing the thickness or increasing the thickness or using any higher Young's modulus value, so that you can change these things in the CAE using the CAE software only. This is a major advantage using the CAE software. So in this, by using any software, you can build this one. You can build the visual test data. You can get all the data, whatever you want based on your priorities. Then you can set for the manufacturing. Then you can take it for the prototype. This is a practical example so that you can understand why we need the CAE software. This is the basic, what to say, this is a theory or the fundamentals behind the using a finite element analysis or to use any CAE software. Next, we'll move on to the HyperMesh. Like what is HyperMesh, how the HyperMesh looks, how the HyperMesh window looks like, we'll see. See, basically the image what you are seeing here, this is how the HyperMesh window look like. As you can see here, the version of the HyperMesh, that is the title bar. These are the menu bars, and we are having a toolbars also. See, the HyperMesh window looks like this. Here you can see the version of the HyperMesh, and it is showing OptiStruct. OptiStruct is a solver, and it is an Altair solver. This is one solver platform that we are going to solve any durability analysis. If you click on the user profile, see, you can see all these different user profile. Since HyperMesh is a solver neutral, it means it will support for the which are the software which are not built by the Altair. That is the external software I can see. These are the external software that the HyperMesh supports. Since HyperMesh is a very good pre-processing software, this is one of the major software which we are using in the CAE industry. This is the profile bar. This is the profiles which we can set. And this is the menu bars. In the menu bars, you can see the file. If you want to open any file or save the file, or if you want to open the new window, all these operations can be done in the file. Then it will go for the edit, view controls. Like in the view, see, this is a view bar. In the view, whatever the views we want, you can keep it. See the names, the same thing, it will appear here also. That's this new file or opening a file. See, it will ask whatever the file you want to open. Since if you are going for opening the file, it will ask the file type. It should be in the HyperMesh software only. As we know, anything you want to open in any software, that the extension should be the same. So for example, if you want to open for Excel file, it should be the ends with the XLS format. So likewise, if you want to open the HyperMesh file, that should end with the .hm file. That's what it is asking. Then we can go for the saving the option. Then the important is the import export options. These are the menu bars which are available in the HyperMesh. See, the toolbar, see, if you are familiar with the toolbar, it is good to work with any software. This is a toolbar, and these are the periphery icons of the HyperMesh. As you can see, this the icons. This is for the mask window. This is for the assembly, creating any collectors. See, creating any collectors, or if you want to create any load collector, system collector, these are the periphery icons which we will be using very frequently. If you want to keep it in a part view, component view, or property view, these are the periphery icons. And these are the different menu pages. As the name indicate, menu pages. If you want to work with the geometry, use the geometry page or 1D page, 2D page, 3D analysis, and the tool and the post. These are the different 7 pages. And if you go for the any page, if you click on the one, if you click on any panel, say I'm going to use the surface panel. If you click on the surface panel, there is a sub panel will appear. It means inside the surface, you want to create any surface, you want to delete any surface, those things will be available in the sub panel. This is the panel and this is the sub panel. Then if you want to run any macros, you can use it. You can run it here using this bar. Then again, the status bar is there. This is the status bar. As you can see, I'm in the geometry page. So it is showing the geometry. And this is the model tree. And this is the model tree and entity tree. I'll show it in a different section. See, as you can see, this is a model tree. As we know, in the model tree, what and all it will come. See, the geometry means it includes surface, lines, points, nodes, everything it includes. So all things we are going to keep it in a components. We can see in the model tree components, load collectors, load steps, material data, property data. Every data will be available in the model tree. Then if you click on any particular component, then the entity will appear. This is the entity view. Entity means inside the components, there are the other things. Let's say, for example, the name of the component, the ID, the color. If it is defined by any properties or the material, those things will appear in the entity bar. These are the main menu icons which we know in HyperMesh. Status bar, menu bars, model tree, entity tree, and the panels and the subpanels in the different pages. These are the basic operation. These are the basic menu bars we should know. In the continuation to the next slide, say next is the geometry import. As I said, HyperMesh is in software neutral. You can import the data from CATIA files, step files, unigraphic files, and the IGS, SolidWorks, and Solid Thinking. These are the different design software. These are the different design software which we can import the data. As we see, for the few softwares may not support for the other softwares, but since HyperMesh is in software neutral, you can import all these data. Likewise, you can export the data. It means importing means I'm bringing some data which is built in the design software. The same thing that is called importing. Likewise, I'm exporting some data or I'm packing some data so that I can export for the different solvers, different softwares. The same only, the CATIA version, if you want to export it, you can do it. Or if you want to export for the, see, this is for the export option. If you want to export for the different formats, see, you can export for the CATIA files, Inspire, JT. See, these are the Parasolid and the step files. These are the different platforms that you can export your data. Since you can import any geometry type of data, and you can import and export the same. Then we'll do some basic operation in HyperMesh. The basic things means once you open any software or any CAD software or any CAE software, we should know how to work with. Let's say basic things means how to rotate or how to zoom in or zoom out, what and all it will contain, what is in component view. We'll do some basic operations in HyperMesh. See, first I'll go with the opening the file. See, if you click on the opening file, see, it will ask whatever the file you want to open. Just I'm opening one file. Just open the, set the destination, and ask whichever the file you want, it will open. As I said, the information it will be available in the, see, this is the right corner, the informations will be available. See, just use the function, just use the keyboard F button, it will fit for the current window. It will fit for the current window. I'm using the control button with the right mouse key just to move around the screen. Control with the right mouse button I'm using. Control with the left button, we can zoom in and zoom out. Control plus left button, you can do these operations. Then if you see, this component, I'm zoomed so much. Then how to bring that one means, just click on the function F button, it will fit to the current window. It will fit to the current window. See, panning, you can move around this window. You can use the control plus right button. Control plus left button will be using for the zoom in and zoom out. Then sometimes we need to fit it in some particular views. See, this view option is there. You can set it for XY plane or ZX plane or a ZY plane or isometric view, top view, front view, like that. Whichever the views you want, you can keep it in that view. See, whichever the views we want, you can keep it. Then what is a component? Basically, whatever you want, or see, I'm having this geometry. On this geometry, I'm going to create some nodes or some of the elements I want to create. To keep that one or to store the elements and the node data, I need something that is called collectors. How to create the collector? You can go here and create. See, I'm going to create the one collector. See, just you can give the component name. You can set the preferred color and say create editor. After doing this one, the collector name will appear in the model tree. See, here I'm having the three collectors. After creating this collector name, the 4 times A, it will appear in the model tree. See, it will appear in the model tree. Basically, the collector means I'm collecting the node data and element data. I'm storing these two in one thing that is called collector. And in the collector, we can save either you can save the nodes, element, or you can save the geometry also. You can save this. See, the flag symbol which you are seeing here, the flag symbol that is meant for the geometry or CAD or surfaces, anything that is all related to the geometry CAD things. See, if you click on these things, see, as you can see here, I'll just mask the elements. I'm displaying only the CAD surface. You can see this is called the CAD. See, this is a CAD. It means the flag symbol which you are seeing here, it is meant for CAD. It representing CAD means it is having some lines, surfaces, those things it is containing. Then this four element shape is there, no box shape, that is called that represents the elements. See, if you click on that one, just go on do the mouse click, it will appear. If you click on, it will appear. Then it is hiding, no, it means it is not showing these things. See, this is called the elements. This is meant for elements. The same elements you can keep it in a shaded mode or wireframe mode. I'll show you. See, now I have kept my geometry in a shaded mode. That means here you can see in the periphery icon, either you can keep it in a shaded mode or shared geometry. It means it is not showing any lines. It is not showing any lines. So like this also you can keep, or else you can keep it in a wireframe. See, this is called the wireframe. But in the wireframe, we can see only the where and all the lines are there. We can see only the lines. Then next comes to the elements. So how the element look like? The same thing, it is available in the periphery icon only. If you want to keep it in a wireframe, click on this one. See, this is a wireframe. This is a wireframe means just it look like a mesh. Like generally, it is not showing any surfaces. See? Like this, it appear. This is how the elements, this is the basic idea behind how the geometry and how the elements looks like in HyperMesh. Then we'll move on to what are materials and properties. See, if you click on any properties in the model tree, it will appear. See, you can change the name of this one. You can create any properties by shell, material. So we need to assign these parameters in the properties. The same properties you can create it here also. See, you can create it here also, or else in the model tree also you can define. Go for the model tree, click on the right click. So you can create assemblies, properties, materials, the other thing. Say, for example, system collector, load collector, laminates, groups. So all those things you can create it. And you can create it here also. See, here also it is available. Material you want to create, properties you want to create, that is available in the menu bars also it is available. Next, we'll move on to topology. What is topology? How the geometry looks like. See, as we just seen in the visualization bar, that's the shaded mode and the wireframe mode, that comes under in the topology. How the topology looks like. What and all this line represents. See, the red line indicates what means, the green means what. So we'll do all these things in HyperMesh. Along with that, we'll do some geometry activity. What is geometry activity or what is topology correction? We'll do it. See, I have opened a different component. Since if you open any CAD data, you can keep it in a preferred view. I'm keeping in this XY plane. I'm just fixing the model in this plane. Then as soon as you open any CAD data, the topology comes in mind. What is topology? The topology is meant for the CAD section. So in the CAD section, what we need to know is, I'm just keeping my component in the wireframe mode. Just observe. See, if you're keeping in this view, you can see some of the red lines and the green lines. what it indicates? It indicates, see the red line what you are seeing, it is indicating the free edge of the component. It means the boundary of the component. Let me change the color of this one. Okay. See, it is showing the boundary color. It means this is the boundary of this component. That is, my component is going to end it here. My component is going to end it here. But inside this, I can see some green lines. I can see some green lines means it is shared between these two surfaces. It is sharing between these two surfaces. I'm creating one extra line just for the representation purpose. See, these nodes are sharing. I'm just creating one line. Okay. It means inside the surface, I can create any lines. But from this point, I cannot create any lines. It means it representing red line, that is the boundary of this component. Either it is the boundary of the component or it is the free edge of the component. That is, this edge is not going to share with any adjacent surface. This edge is not going to share. This edge is not going to share with any other surfaces. So the green means it is a shaded between the two surfaces, whereas the red indicates that is the boundary of this component. This is the basic idea. We should know what comes in the topology section. Either we can call it as a topology addition, geometry correction, or CAD correction. These are the different terminologies which we use in the CAE industry. We have know what is the geometry representation. Just we have learned. Then we'll move for some geometry activity. So in the geometry activity, what we should know, that is see, once you open any software or before starting any work, there are some prerequisites are there. That is, before you start doing the machine or before you start creating the elements, you should analyze the CAD. You should come to a clear picture. Okay, the CAD is ready, then only you can start the mesh. So how to rectify that one or how to correct the CAD? See, I have just imported one file. I have just opened one file. In the periphery icon, I'm switching on the points. I'm just switching on the points. See, the gray ones, the gray dots as you're seeing here, the gray dots indicating the points. There is a difference between point and the node. I'm just showing. See, the yellow ones, what you're seeing, these are the nodes. The gray ones are called the points. Okay. I've just opened this one CAD and I've switched on the points. By going with the point, I should start analyzing the component, or I should start what are the things are missing in the surface. That means as we are importing the CAD, since this is not the build, this is CAD, sorry, this CAD is not built by ourselves. This is the CAD which is built by the design engineer, and he has given for us to do the meshing. As we are importing this file, like our project requirement is different compared to the design engineer, or else there might be in software compatibility issues. There is a missing surfaces or duplicated surfaces. Those things will be there. So what we have to do, we need to check for the surfaces, or we need to check. We need to analyze the things. How to analyze the things? I'll tell you. As soon as you open any window, after opening any CAD files, we should start searching for the things. Okay, what are the things which are not required? See, I have just duplicated one surface. See this, you can see the yellow lines. It means it indicates the duplicating surface in the HyperMesh. The red means free edge. Green means there is a shade between the two surfaces. Yellow means it is duplicated. The line is duplicated. So all these things I should take care before starting the machine. So first I'll go by deleting the duplicating surface. The deleting option is available in the functional key F2. Sorry, these are the major functional key option we should know. The F2 button we are using for deleting the surface. You just observe. See, if I delete the surface here, the things are gone. Why? Because here it is not duplicated. I can see only the green lines. But if I come here in the F2 button, If I click on this one, I see, you can see some graphical, see how the surface is acting. It means it is duplicated. Say delete entity. What I did, I have just deleted the surface. I have just deleted the surface. Why I have deleted the surface? That is a part of the geometry cleanup. That is that I need to take care before I proceeding for the meshing. So what we are doing in the topology correction, we are deleting the duplicated surface. We are deleting the unconnected surface. We need to create the surface. We need to create the other surfaces which are required. So one operation is done. Next, I can see some of the red line in between the component. See, in between the component. Here, one circle is coming. One circle is coming, and it is a valid reason. We have seen the practical examples of the component that it contains some bolts or nuts. So the circle is coming. So here, the same red line is appearing. It means it is a missing CAD. So missing CAD means here I need to create the elements, but I don't have the surface. So I need to create the surface. How I can create it? I'm going for 2D page. I'm using the ruled option. I just want the surfaces. In this drop down, I'm choosing lines. Okay, now select the line. From here to here, I want. And I'm choosing this line also, say create. See, line as created. Like this, here also I'm creating. This is my first line and this is my second line. Say create. And you can see one more doubt. You can see one more thing you can ask me. Okay, here the surface is missing. So there is a reason for the missing surface. But here the surface is there, but still there is a red line. It means these two lines are not stitched. It means these two lines are not connected. See, I'm zooming the component. You can see the gap between these two surfaces. It means the surface is not stitched. How to stitch that or how to connect these surfaces means go for geometry page. This is the quick edit page, quick edit panel. This is one of the important panel which we use for the major geometry corrections, for the major geometry corrections option that is available in the geometry page quick edit option. Here the toggle option is there. See, just click on this one. See, it means I'm stitching the lines. See, I'm just stitching the lines. So this geometry correction is also done. I'll come here and I'll stitch it here also. So like this, you need to correct it. But if I do the same toggle value here, it is not going, it is asking the gap. So this is not the correct way. So don't do this. And if I come here and if you click on the toggle, see, I cannot toggle this one. You can observe in the status bar, I couldn't stitch it. The gap it is showing 289. See, it means here I cannot stitch it. So here the stitching option will not work. But here it will work. See, HyperMesh is, we should analyze the things, how we can correct the geometry. Okay, we have corrected this geometry. Now here also I can see some of the surface is missing. So either you can go by the 2D ruled option, you can go and you can fill this surface like this. You can fill this. See, surface is created. One more option is there. Go for the geometry page, the quick edit panel only. Fill the surface is there. Either you can go and choose anything that it will fill it. See, if you go and click on the circle, the surface is going to create. Likewise, if you want to delete anything, here only the delete option is available. Delete the surface. It will not ask you the second, or it will not give you a chance to select the other thing. Directly it will go and it will delete. So the HyperMesh is having some undo and redo option. You go for Control Z, you will regain the surface or it will retrieve the surface. The same option is available here also, for undo and redo options. The delete option is available, the surface delete option is available in the quick edit panel also. The same thing which is available in the functional key F2. The functional key F2 is meant for deleting. So what and all you can delete? The operation what you can work, like creating elements, surface, load collector properties. Likewise, you can delete all these things. You can come for F2, select whatever you want to delete. It is available in the 2 pages. See, you can select whatever you want and you can delete it. or else go for the model tree. Go for the model tree, select the component and you can delete it. See, here also you can duplicate or deleting. These options are available in the model tree also, and in the F2 panel also it is available. I'm going to fill all the surface. I'm using the ruled option. Choose the line. One more time I'm showing. Choose this one and create. So likewise, you need to select all the lines and you need to create the surface. See, I'm selecting all the lines, whichever I required. I'm just creating the surface. Here also, you come and choose the line. This is the topology correction which we need to do before we carrying the meshing. See, in a single shot, I'm selecting all the line. In a single work, I'm doing all these things. See, it will create it. Or else directly go for quick edit. Fill the surface also you can use and you can fill it. See, fill the surface, you can fill this one. Like this, you can do it. And one more thing, if you don't want these points, you can go here. Here the remove option is there. Click on the right button in the mouse key, it will go. See, this point will go. Why? Because this point is not sharing between any other surfaces or any other lines. So it will go, but whereas this point will not go. See, I'm trying to remove this one. It is not going. Why? Because this point is sharing between these two surfaces, or with this line, it is sharing. Likewise, if you want to create any points anywhere between the geometry, you can create it. How to create it means, click on the surface, hold the control button. See, choose the surface, choose any surfaces. I'm choosing the surface. Do a long click on the surface, then start clicking on the mouse. The points it will create. So likewise, if you want to create any washer to represent any bolt holes, as we see in the practical examples, to represent any bolts, to represent any bolts or nuts, it will be having some washer. The coin shape, the part will come with the bolts or nut. That is called the washers. The same thing we can represent in the CAE software also. That is, select the washer, give the washer value and click on this one. Automatically, the extra line will get created. The extra surface will get created that represent the washer to this circle, washer for this circle. These are the basic operation. These are the basic topology things we should know before we start doing the meshing or before we start creating any mesh. Since we have learned the geometry addition option, in that we have learned how to create the washers and how to create the new surfaces and all. And if you want to create any lines, see, I'm selecting this line and I'm choosing here. See, I can create the line like this. I can create it. But if you want to go for continuous line, means the second option you go, that is the split to surface. Click on the node wherever you want to create. The exactly opposite side, it will create the new line. But if you want to create some nodes, if you want to have some split lines from here to here, you can use node to node. But if you want to have a split line exactly on the opposite line, means you have to go with the node to line option. So node to line option you can use this one. By using this one, you can, however you want, you can split the geometry. Basically, the finite element analysis is splitting the CAD. That means I'm discretizing CAD to create the element. Why I need to do the topology correction? I want a correct geometry. I want a good geometry to create the elements. If the geometry is very good, I will get a good elements. If the elements are very good, definitely the quality parameters will not fail. If the quality parameters are too good for the component, then we will get the correct results. Or else, or in a shorter way, I can tell, the results of the finite element analysis is directly proportional to the quality of the elements. The quality of the elements depends on the geometry. So if the geometry is good, definitely you will get a quality of elements. How to get the good geometry means by doing topology correction. Topology correction means deleting the unconnected surface, duplicated surface, and creating a new surfaces which is required for the CAD, and splitting the CAD as per the requirement to get a good elements. This is the concept behind the topology. So topology operation is it is one of the major thing which we do before we creating any elements. This like what and all things we have discussed, this is only for the geometry section only. So geometry section, it comes for the surface addition, surface creation, deletion, or creating washers, creating lines, surface edit. These are the topology corrections, are the geometry editing. And we are geometry editing, and we have learned about the file management and importing the CAD view controls. We have learned repairing the CAD means that is the topology correction or editing the CAD. That mid surface and all we will take it in the module 2. There where we are going to extract the mid surface. We'll learn why to extract and how to extract the mid surface in the module 2. And I hope you understand all the concepts what I have discussed on the topology correction and the finite element analysis, that what and all the things we should be taken care for the CAD before we proceed for the meshing. In the module 2, we are going to discuss about the elements and the mid surfaces. Thank you. If you are having any doubts related to the today's session, you can ask in the chat box. I'll answer those. Thank you.
Thank you, Tara. Thank you for the session. Guys, if you have any questions, you can leave it in the chat box. She's here to help. I think there are no questions. Tara, do you have any questions regarding the certificates of this course? How will we receive it? You'll be receiving the certificate link on the 3rd day. During the session, we'll provide a link to generate your certificate.
Yeah, I'll show it again. Somebody is asking to filling the surface.
Yeah.
See, first I will delete this surface. Directly I'll go for the quick edit. I'm deleting this surface here only. I'm deleting this surface. Either you can go by filler the surface. See, the surface is filled, or else you can go for 2D. 2D, the geometry, the ruled option. This is the shortcut way I'm telling. The line. Select the first line and select the second line and say create. So like this also you can create it, and again you go for the geometry page for toggling this one. See, you toggle this one. Select the 2 lines and give some the tolerance value. Based on the tolerance value only, the value, these 2 surfaces will get stitched. These 2 things will get stitched. This is the filler option will work. Any other question related to the today's discussion, you can ask in the chat box. Yeah, for solid model also we need to do topology corrections. It is required for all the CAD. Thank you.
Any more questions?
Okay, thanks for joining the call. For tomorrow also, we are having the 2D modeling. For the module 2 also, you can join, and there we are going to learn the how to create the 2D elements by extracting the mid surface. Thanks for joining the call.
Thank you. Thank you very much.